Meteorologist Chris Haddings here. Past couple of days have been very, very windy across the area. You can see by this picture here, this was taken in Riverton early this morning. Very strong winds across the area last night. Peeled this roof off of a auto repair shop along Federal Boulevard. And these should continue in some places through about today, but you may wonder why these strong winds have so much force. And I was curious, how do you calculate this? We'll start by taking a look at some of those wind gusts, though. You can see about 88 miles per hour on the Chief Joseph Highway. Many places in Park County seeing hurricane force gusts. And around much of the Fremont County area, wind gusts between about 55 and 70. Now, I'm warning you, there will be some math with this. I know some of you are thinking, you told me there was no math. There will be a little bit of math, not a lot. We're not talking calculus or differential equations here. And also some science. Now, how we calculate this is using something that's called kinetic energy. Now, we have two kinds of energy generally in physics. The first one's called potential energy, the other one kinetic. Now, potential energy, let's think of a spring. When you compress that spring and you hold it in, that spring obviously has some energy stored in it. That's what makes it go back up. Now, potential energy is when you compress it and it's stored, and it releases kinetic energy when you let the spring go. And the technical term for it is called energy of an object that has reason of motion. Obviously, when you get wind, it's moving. And we have an equation for this. Not a real hard one, don't worry. I'm not going to expect, there's no test on this, don't worry. It's a kinetic energy, that's Ke, 1/2 mv squared. Now the m is mass, and the v is the velocity of the object, in which case we'll just determine that as the wind speed. Now, the mass of air is fairly constant. It can vary by a few percent, depending on what the atmospheric pressure is, but overall it's fairly constant, so we'll just eliminate that term. And so we get kinetic energy of that is equal to the square, basically the velocity of the wind squared. Now I know there's a lot of units in there. Math teachers, science teachers don't at me on this. I'm trying to keep this simple. This isn't a math test. In any case, when you see a squared number like this, those of you that aren't really familiar with a lot of math, basically just take that number and multiply it by itself. So 2 squared would be 2 times 2, 4. 3 squared, 3 times 3, that would be 9. And the force of the wind actually increases exponentially. That's what we call it, as that wind speed increases. Now an example real quick here. Wind speed of 25 miles per hour. A lot of places in the country call this breezy to windy. A lot of places in Wyoming, we call this Tuesday. In any case, we'll take that wind speed and multiply it by itself. That's squaring the number. And we get a number of 625. Now remember that number. Now let's ramp that wind up quite a bit. We'll go up to 75 miles per hour. It's minimal hurricane force. However, some places, say like Outer Drive along Casper, tend to get this once or twice a year. And also some of the windier spots, but just about anywhere in the state can get this in a good windstorm. So we'll do the same thing there. 75 times 75, we end up getting a number of 5,625. Now I know you're thinking about the wind. Usually you think 75 mile per hour wind, 25 mile per hour wind. Now logic would tell you that's 3 times as strong, but that's not true. It's actually more than that. So we'll take that number, 5,625, divided by the number we got for 25 miles per hour, which is 625, we get a difference of 9. That basically means that a 75 mile per hour wind has approximately 9 times more energy that's exerted against objects than a 25 mile per hour wind. That's why you see the damage really starts ramping up when you get to that point. If we bump it up to 100 miles per hour compared to 25 miles per hour, it's 16 times more powerful, not 4 times. That's a quick calculation of how to calculate the force of the wind. Hope I didn't fry your brain too much. Enjoy the rest of your day.